We will be applying the Feynman method in our studies throughout the year. Because this is a research course, you're going to be constantly running into, exploring, uncovering new concepts and ideas that you have never began to even think about. And as you do, I want us to, for each new concept, apply the Feynman method. And I've formalized it a bit by creating a set of documents that I want you to continue to add to. And so if you look inside of your team folder, you'll see there's a concept map and a glossary. And the concept map and glossary are going to be living documents that you're going to be continuing to add to. If we look inside the concept map, you'll see an empty table that looks like this. And the topic or concept or theory is going to go at the top. We're going to have a concept theory description, which is going to be in your own words. And then we're going to have the comparison model, which is the analogous situation. For a 2D array, the analogous situation that I came up with was a board of Connect 4 flipped upside down. And if you go ahead and read through this, you'll see that I kind of come up with this, kind of unusual situation. But once you visualize it, then there is little doubt that you'll understand how a 2D array is iterated through using a nested for loop. And for those of you who don't know what 2D arrays are, you haven't taken a computer science class before in the past, don't worry about it too much. And then for those of you who have taken the AP computer science course, just bear with me here. And the next section is the application section. And this is asking where is this concept or theory used in real life, right? And so for 2D arrays, so what I listed here is that it's used for image manipulation, right, to represent the data of that's stored in an image. Whenever you extract data from a database in a web application, it's all extracted using a 2D array that you iterate through. And let's see, video games use 2D arrays to contain information about a map, like a character running through a World of Warcraft. The 2D array lets you know when you are close to an enemy or a fellow teammate. And then also I give the example of machine learning using 2D arrays to process data through a neural network. And so the applications, this is all the result of your studies, the result of you going to a textbook, you going to an online PDF or YouTube videos, online text sources, and the resources that you use are going to be right here at the bottom. And actually, a better idea is to put the resources here and the explanation video here. So let me go ahead and delete that. So we have our resources that we used here. And you can see we have some YouTube videos, we have some Stack Overflow, we have some documentation, and so on. So basically everything that you kind of used online is going to be here, and this is not limited to just online sources, but also textbooks, any written material, physical written material you'd want to use, the regular way of referencing those sources. And then lastly here would be an explanation video, and I'll show you how to do this, but it's very simple to create a screen capture video. And so this is going to be exercising the teaching part of the Feynman method, right? And so you're going to sum up all of your studies, all of the data that's in this chart, using all of the online resources, videos, pictures, graphs, through an explanation video. Right, so you'll take a video of your screen, and you'll walk the viewer through this concept using your description, your comparison model, your application, and also any of the visual resources that you have come across through your studies. And so that is the concept map, and this should be growing bigger and bigger and bigger, or having more and more entries as we proceed through the course. And at the end of the course, somebody can view your final product, your final report, and they are going to be lost, completely lost, and they will not know where you're coming from. But if they come back through your concept map, start at the bottom and work their way up, they'll say, okay, so then this idea is used in the construction of this second idea, and then the second idea is used in the understanding of this third idea, and so on and so forth. And this will kind of provide a key that will unlock the meaning behind your final presentation, right? Or at least have a pathway that goes through and shows how your understanding was built over the course of time. And then we have a glossary, and of course we're going to be running into many different words that we have no idea what they mean. And the glossary is pretty straightforward. I just want the term and the definition can be copy and pasted from a online resource or a text resource, right? But if it is copied from a resource, then we want to go ahead and reference them here in this column, right? And then lastly, as these vocabulary words are used in the concept map from the glossary, what I want you to do is create a link, right? Do you see that? So let's say this is the vocabulary word that's in the in the glossary. Well, I linked it to the glossary, and it takes me right to it right here. And so how do you do that? Well, I guess I can go over that in a separate how-to video. And yeah, and that's about it. And I guess another thing that I want to mention is that you are going to be required, you're going to be paired up in twos, and you're going to be required to add at least three entries each into the concept map. And that's not to say that two people cannot work on the same concept. So you see here we have red. That lets me know that person A has worked on this, and person B has worked on this portion here. So if you do, as you enter in your work here, go ahead and color code it for me so that I can give appropriate credit where credit is due. And yeah, that is how we're going to be using the Feynman method in our studies.